project. Our problem definition is that our group was tasked to identify which main factors in the Stratapult setup would significantly increase and influence a distance the projectile is launched. It's going to allow us to determine any notable interaction effects between these factors, and through data collection and statistical analysis, we're going to gain the knowledge to inform and follow up on experiments that are ultimately going to be able to design a statistical model to use as a targeting solution for the Stratapult. For our actual experimental design, we chose a 1/2 factorial design for our experiment. We decided to use this design as it allowed us to perform more replicates throughout our experiment, giving us more precision and accuracy throughout. We chose to test the hook position at 2 positions, number 1 and number 4, as well as the stop angle pin at number 2 and 5, then the tension pin at number 1 and 2. And then finally, we also chose to change the ball type. It was either a wiffle ball or more of a foam type of ball. Our data collection went very smoothly overall. We only had 2 group members during this day, but overall went very smoothly, and the only error we really see would be human error, because we didn't have a camera or any other type of technology actually measuring the distance of the ball. So we just had to rely on the human eye and tape measure.
For the statistical analysis, we did this using RStudio. The first thing that we did was we changed all the variables into factor data types, because this allowed them to be treated as categorical variables by R. And if we forgot to do this, then they would have a major influence on all of our plots and models, and then it would just mess up the whole analysis. So after that, we plotted all of the different variables as box plots to see the 2 different positions and how they worked, as well as we plotted a histogram for the distance of every observation that we made. So these plots that you can see before you were all very informative for us, because we were able to compare the centers of each box plot and see which version of the variable produced a further distance. If we saw a super big difference in the center point, then we might be able to, we're able to see that something like the ball type box plot might not be a statistical difference between the 2 different ball types used. And that was concluded through that box plot. And so we were allowed to look at that when we were doing the rest of our analysis. And then the histogram shape allowed for us to conclude that its shape was normally distributed. For the regression, we first did it with all of the different variables. However, after we ran it, the p-value was very high for ball type, so we reran it without ball type, and this confirmed that ball type was not statistically significant, the 2 different balls. So we used that regression to go on with the rest of our analysis.
Okay, then we checked our model assumptions using the QQ plot and residual versus fitted plot. The QQ plot showed residuals following roughly a straight line, meaning they were approximately normal. And then the residuals versus fitted plot showed like a curved smiley face, more of like an uneven spread. This tells us more about the linearity assumption. Well, it basically failed the linearity assumption, and it also failed constant variance, so homoscedasticity. This doesn't invalidate our findings or our experiment. It just shows that we could have like more improved future studies. So then we checked it. We also tested for multi-collinearity using VIF. All VIF values were 1, and since VIF is less than 10, in any case, no concern that we have to worry about. Then we checked it against, then we ran ANOVA using against the QQ plot again, and ANOVA confirmed the same results as the regression did. The hook position, stop angle, and tension pin were significant, and ball type was not. The diagnostics of ANOVA model produced the same QQ plot and residuals versus the fitted pattern, since both models share the same underlying residuals.
Finally, we did the interaction plots for each of the different variables next to each other. Parallel lines show no interaction, while any crossing lines shows a potential interaction effect. We only had one potential interaction effect, and that was with the stop angle pin and the ball type interaction graph. So that meant when the stop angle pin was set to 2, the golf ball went a shorter distance than the wiffle ball did, but when the stop angle pin was set to 5, the golf ball went a longer distance than the wiffle ball did. Basically, in conclusion, the hook position, tension pin, and stop angle pin all had a statistically significant effect on the launch distance, and our recommendation to you as our senior leader is that you run more intensive experiments on these variables and their effect on how far the Stratapult can launch a ball.